Go over to our working project that I did earlier, which is I put it in a folder. I call it Johnson. Inside that, Johnson 4. What I like to show you now how to assign field programmable gate array pin name for the user level. So this is the schematic that we have discussed earlier that has been completed. And as you can see, this is the TC that I mentioned to you. This is the reset line. And the output of the data flip-flop, I hook here a port A, A1 here, B, C, 1, and D. And that's all it is. But we have to assign to it a so-called user configuration file. So we got to, which is this one here. Okay. So, of course, during the process of developing this, you don't have this user configuration file yet. That should be assigned to those. To do that, we have to activate the so-called user constraint and invoke the edit constraint file text, and it should open up this one to be supposed to be completely empty, right? So you have to fill this up. What you need is to use the user manual in order to find this FPGA assignment to the user. What I will show you is the simplest one. Just go to the course website, go to the college homepage, click the FPGA under EE404, scroll this under step number 5. We have a much simplified alternative UCF generator written in Excel code. Click that to open, and in the column A of the spreadsheet, enter the name that you want to assign to your clock. I believe we have in the schematic decided to call that CLK50. Notice when you click somewhere outside of that, this will be filled up with the assignment right there. CLK is assigned T9. And this one, I believe I assigned that to reset, right there, L14. And then for slide switch 0, I assigned the clock enable. And then for the LED 3, I assign A1. This is B, output of the flip-flop, data flip-flop, that is C, and I call this D. Oops, notice that's wrong. That should be D. So change it, click, then you got all what you need. Then what you do is just pick the yellow background generated UCF, right-click, select copy, go back to the Webpack, highlight all of this, and paste it on it, and that will be transferred here like this. Then you click save that, which is already available. That will be saved under Johnson 4 UCF. And then you point to the top schematic module, select process, implement the top module. processes. There, should start out pretty slow. Let me see this. Let me double click the video synthesis report. It's compiling. Okay, that's the report. Now we can even see the view of the RTL assignment for our schematic encounter right there. So it's represented by black box whose input is 50 megahertz and reset, and clock enabled. The output is this 4-bit of the Johnson counter. Let's go back to the processes and source. I think that's the source. Now I'm going to click the implement. Okay, it's running. Let me close the implement and user constraint. Okay. While that's going on, I power up my board, and I'm using USB JTAG from Digilent cable that goes to the JTAG on the board to the back USB port on the back of my desktop computer. We will ignore the question mark, sort of yellowish warning. Then on the generate programming file, since I'm using Digilent, I simply double-click generate programming file folder. When the lower one turns to green, then the file should be ready. The bitstream file is ready for our use to be downloaded and burned at FPGA. Meantime, I like to click decline this dialog message to be sent out. Now, see, we have a programming file generation report. I will open up the folder to show you what has been generated there, which is this one here. The one that we can download is this one here with 128 kilobyte bit file type, Johnson 4-bit. So we will do that. We have to open up the export utility tools, which is this one here. Double click that and click the initialize the chain. If you see these two devices, it's okay. Then I will check to remove the other device, and then I will browse the folder and make sure you see the configuration file. Open that, click yes, because it's already, and then click this programming the chain. Then it's working now. My board LED bit 0, 1, 2, 3 is now displaying the Johnson 4-bit ring counter sequence. So that is the end of the demonstration. Okay, I will generate a video tutorial for this.